fair question, and to answer it, I've put the original equation here and the intersecting line here. Now I've put this slider here, and what you should be able to see is for values of k is just affecting the gradient of the line. It goes through the origin, and as you can see, there's some places where it doesn't intersect at all and others where it does. Now when the gradient line is -2, we've got a point of intersection right here. Okay, so it's tangential. Then if I go into that or lower, where k is lower than -2, we can see 2 points of intersection. Now this can keep going lower and lower, infinitely smaller, until this line is perfectly vertical, and that way it's always going to have 2 points of intersection. So when this goes to -infinity, that's going to be perfectly vertical. On the other direction, if you go up to -2, and then beyond that, there's a space here for which it doesn't touch the line. But the same thing will be true in the other direction. It goes all the way up to where about that -2/11 is. Okay, so this is just a little bit higher than it, so it's not quite touching just here. But we can see it's very close. But when we get to that -2/11, it actually goes into the line, and below it we have the same situation. So it's going to get positive higher and higher and higher until it gets to infinity again on the other side, where the same thing happens when it gets perfectly vertical eventually, and it will always have 2 points in the intersection. There's a small part between your -2 and your -2/11 where it doesn't intersect. So hopefully that helps understand visually what the values of k can be for there to be an intersection or two roots between this line and this circle. And just to be clear, it's not always going to be a change in gradient. They might have this set up in another way, but ultimately, if you're using the discriminant, this is the power of the discriminant, you can identify the value for which there's going to be your 1, 2, or no roots here. So it's not always going to be a gradient. It could be an intercept, it could be another function, but as long as you're using the discriminant, you're going to be able to use it to find the values for which the levels of intersection are true.